Hi, I'm Anton from Southern Federal University. Usually, quantum cryptography is touted as a better solution compared to classical cryptography when it comes to distribution of public keys. Now we have quantum key distribution systems. Actually, there is a lot of research done globally in this area, but only a couple of systems have seen commercialization. In Russia, we have about 3 or 4 samples like this, and I'm working with one of them. But that was a fault with one of the systems. Well, the way they work is that they code the current state of a photon being transmitted. Pure physics, no math to it. I'm not talking about data encryption here. All I'm talking about is creation of a fully, totally secret quantum key. That's what these two units are designed for. So we've built a light bench, and we took 2 computers to use them as crypto gateways. Then in a point-to-point mode, we started an Ethernet connection. And this is the bench as we made it. Oh, this is the basic configuration. You can easily scale it. So keys will not be transmitted over the fiber optic network. Instead, keys are actually created, so to speak, minted on the 2 computers. So these are essentially hardware encryption modules. So quantum cryptography systems are actually produced without manuals. They are exported mostly. It took us 2 years to reverse engineer the whole thing. Now we have spent these 2 years developing the protocol, and it creates like 500 bits per second, which is very low. 2 computers will establish an IPsec tunnel, and we get a one-time path like this. So we are showing here 256-bit keys, and each of them has an ID. Please know that files are simultaneously created on 2 computers, and no data gets exchanged. Then we will manually integrate these keys in the IPsec protocol. It's a pretty primitive configuration. 4 ways encryption is done with 256-bit keys. And we did IPsec dumps in order to check and verify the whole thing, and indeed it does get encrypted. I am showing a pretty primitive configuration, but I believe it holds significant promise. You might say there are no quantum computers out there, and you're right, but the system is already working. Actually, they were used already in Olympic Games, not here though. They're very much used in US, France, Switzerland, Japan. In Japan, they're not publishing anything openly. Only Switzerland is selling such systems now. The US has banned sale of such systems. We can grab existing systems and develop our own protocols, so we can also develop our own protocols and our own encryptors. Now, if we do that, we won't have our own licenses, and therefore serious customers will not use them. I actually believe we've got what it takes to develop a system like this, because we've got good programmers, good developers, good engineers. So in the future, we should be able to develop such a system for quantum distribution of keys. Thank you very much. Hi. Well, this essentially means that you will have session keys that are symmetric No, they are not session keys. Just a string of bits. And then you can easily cut it into keys of different lengths. But it will be the same key on both sides, absolutely. And why do you need to send photon states? Do you need it to synchronize it all? Well, it's not like we send the photons over the network. We send the quantum state of the photon to assure we have the same keys. And the quantum optical channel is obviously a prerequisite, that's right. So in order to start industrial operation of this system, you will need any Ethernet and this quantum optical connection. Understood, thank you. Do you have other questions? What are the requirements? Is it a single mode, double mode, multi-mode? Oh, it could be anything. I experimented with 50-kilometer single mode fiber. Well, the most important requirement is a single photon detector. It has to be a high quality box. So it can be any fiber, but the SFP has to be very special. Absolutely. You can use any regular fiber, really. You mentioned 50 kilometers. And the speed you mentioned, is it for 50 kilometers? Well, actually, the same speed will be maintained at distances of up to 100 kilometers. Now, photons will move in two directions, which means that 50 kilometers of length actually means 100 kilometers of distance, real distance, right? So the strength of signal is 0.1 photon per impulse, which means that in every impulse you'll have a pretty low signal. I understand that you bought ID Quantic, that's right. Now, why didn't you use a Russian system? Because they actually come with very good manuals and descriptions, and all the protocols have been described. Well, there is a good system at MSU. Well, what they have is a pseudo system, because they don't have quantum generators. So they do have quantum generators. They use foreign equipment. For example, single photon detectors. Yeah, but ID Quantic systems are vulnerable to hardware attacks. So what do you mean? I mean overexcitation attacks. Because it sounds like you did extra work. Why would you spend 2 years decrypting and reverse engineering the whole thing? And by the way, how do you clean the key? Is it done over the Ethernet? No, it's done over quantum cryptography, either BB84 or 92. But you need two channels, right? One is quantum, and the other channel that you need for key cleansing, for synchronization, you might call it. So how do you do that? Over the Ethernet? Well, the quantum key itself is generated over the fiber optic network. So what we did was to take ready-made keys, and then we reshaped them and we integrated them into IPsec. Is there a description for how the protocol works? Oh yes, sure, but it's confidential. Well, there are loads of problems there. Oh, absolutely. Well, I would recommend that you actually look at our system, because with the MSU products, you at least know what you should do. Well, based on my understanding, they're not actually mature enough. Well, ID Quantic, I'm sorry, is actually a very stable system. Well, MSU system is equally stable, and it does auto fine-tuning, because you're dealing here with a black box, right? You've got no way of being certain that the decryption, so to speak, is proper. Take MSU guys, for example. They've analyzed the randomization engine they're using compared with ID Quantics. There is no quantum nature to their randomization at all. I'm afraid you're wasting your time. Well, I disagree. Well, I disagree as well. Thank you very much.